Today I'm going to talk about LeetCode question number 198, house robber. So you're a professional robber, plan to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses are broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So in one night you have to rob houses and get the maximum money you can rob. And you can't rob two houses that are next to each other or else the alarm system will go off. Okay, so for example here, you can rob this house and this house. Rob this first house, skip the second, rob the third to get 4. You can also skip the first, rob the second, and obviously you have to skip this third, and then rob this fourth to get 3, and obviously the answer here is 4. And for this case, we can rob first, third, and fifth to bring the total to 12, or we can rob the second and fourth to bring the total to 10. We can also rob the first and say fourth and fifth to bring the total to 3, 4, 5, 6, etc. Any sort of combination, so as long as the houses are not next to each other, and it turns out in this example the answer is 12. So you might be tempted to say, well, why not just add up the even positions, like this position index 0, 1, 2, 3, 4, since this is 0 indexed. Why not just add up all the even indexes and then the odd indexes and get the max? Well, that won't work in this case. Why not? Let's say we have this example here. So this is index 0, 1, 2, 3, 4. Okay, what if we were to add up all the even indexes? So 0 plus 0 plus 5. What about all the odd indexes? 1 plus 0, 3, or 1 plus 0, 1. So would 5 be the maximum? Well, no, because what we could have done was start as this first house here, house at the index 1, skip these two houses, and then rob this very last house here, bringing the totals to 6 actually. Okay, so that's why only adding the even positions and odd positions won't work. So what could we do in this case? Well, this is a good dynamic programming question. Because for each index we're at, we have to make a decision whether we're going to rob that house and skip 2 houses ahead, or skip the house and see the next house. And for that next house, also decide, are we going to rob it or skip to the next house and see the value, potential rob value there. Okay, so let's just take this first example here. So right now I'm at index 0, and I can either rob this house and head to this index, so that'd be 2, or I cannot rob that house and skip to index 1. I'll write this bigger here. Okay, so we're at index 2 in this branch, 0, 1, 2. Same thing, we can either rob it and move 2 spaces ahead, and obviously this is out of bounds here, so we stop here. Or we can skip it and move on to this next house here. 0, 1, 2, 3. Okay, and then same thing, we can either rob, move 2 spaces ahead, obviously that's out of bounds, or skip it And obviously that's also out of bounds. Let me calculate the total. So this would be 3, this would be +1, +0, +1, 2. Right, 0. Yeah. And this would be just 1. And what about this guy here? So if we're at position index 1, we can either choose to keep it or rob it, and then move 2 spaces ahead to index 3, or skip it and move 1 space ahead to position 2, and so on. Okay, so as we can see, we want the maximum we can rob at each position here. So this basically becomes a bunch of sub-problems here. So like this becomes a sub-problem. What are we going to do at this decision when we're at index 3? Same thing here. And similarly here at index 2, at index 2, and so on. So that's why this is a good dynamic programming candidate, because we're solving sub-problems first. Okay. So how can we solve this? Well, a good way is recursively. We can recursively go down this decision tree here. You know, before we calculate the maximum value of position 0, we calculate the maximum value of position 2, and also the maximum value at the index 1, and so on, and get the maximum. And get with using those max, we bubble up back to 0. So like max, and these are the indexes. We can also do this iteratively using an array instead of recursion. So what we can do is, so we have 2, 3, 1. And then these represent 0 houses. Okay, so we have these houses here. And these represent, you know, the base cases are, I guess, are out of bounds. So what we can do here is, so remember here we have 2 choices, either keep it, or either rob it, or skip it. So what we're going to do here is do maximum of itself. Okay. Or that means a kind of a skip it. Or maximum of 1 plus 2 spaces ahead, which turns out to be 0. And turns out the value here is 1. And similarly here. Okay, so that maximum is now 1. And similarly here, what we want to do is max. And we also want to keep like a maximum max val variable, which is right now is 1. And here, which is now 1, it was 0 previously, now it's 1. And here what we want to do is max val, and which represents where we're not robbing this house, or we are robbing this house, and we're going to look 2 spaces ahead. So 3 plus 0, which turns out to be 3. Okay, so now max val is 3. And similarly here, max of max val, and then 2 spaces ahead, 2 plus 1, which is still 3. And here, max of max val, which is 3, or itself plus 2 spaces ahead, 4, which is going to be 4. And now we have our max val, which is 4. So you see what we're doing here is we're calculating the maximum that we robbed so far, and for a particular index, we can either choose not to rob it and keep the max value we have so far, or rob it and look at the 2 houses ahead and add it to this robbed house total, and we keep whatever the maximum is. We keep the maximum of whether we rob it or we don't rob it. Okay, and this is O of n space because we're keeping an array, and O of n 1 time because we're just iterating through the array once. Okay, so now to code this up, so what I want to do first is append 2 zeros at the end of nums. So okay, this will represent our base cases. So this guy will look like 1, 2, 3, 1, and then 0, 0. Okay, and I also want to keep a max val. Okay. Now I want to iterate through nums backwards. So for I in range nums minus 3 plus 1 minus 1. Okay, minus 3 because remember we just added 2 zeros at the end. Those are the base cases. And we want to start off at 1 here. Okay, at this first house that we could potentially rob instead of those out of bounds base cases. So we're going to start here, minus 3. And what we want to do is assign max val to be the maximum of itself, or nums at index I plus nums at index I 2 spaces ahead. Okay, if we start here, we want to look 2 spaces ahead, which is why I added those 2 zeros. Okay, so that's going to be our max robbed value so far. And then what I want to do is assign nums I to be equal to max val, because this represent at this index here, this is the maximum that could be robbed so far. And then we go backwards, and then eventually we'll reach the end, and max val would represent the maximum we can rob that night. Okay, so try running the code here. Okay, and I'll submit it. Okay, cool. Thanks for watching. And I said this takes O of n space, but it looks like it takes kind of O of 1 actually, because we're reusing nums.